In this topic, we'll talk about the method of purification. So, how you can purify the substance. So, before going to that, we need some definitions or some terms we should know before you are going to define them. For example, you should know the what do you mean by pure substance. Pure substance means, for example, now the pure substance like element. For example, you have sodium and you have one piece of sodium. If you see in this sodium, there are million of atoms of sodium, but all the atoms are same in structure, in atomic number, everything is same. If a substance is made of only one type of atoms, if the substance is made of one type of atoms or single type of atoms, so that substance is known as pure substance. Not only atoms, sometimes molecule also known as a pure substance. For example, you have water. Now, water formula is H2O. It means water is made of two elements, hydrogen and oxygen. So, when they combine together, they make water. So, if you talk about water molecule, so water molecule look like this. You have oxygen and two hydrogen atoms are attached like this. Then they make H2O. If you have a water glass, inside this water glass, if all the atoms, they are water atoms, all the molecules are water molecules, then this is also known as a pure substance. So why I'm explaining this one? Because don't think that only elements are known as pure substance. No, when sometimes the molecules, if all the molecules in this glass, only water molecules like H2O, H2O, then this water is also known as pure substance. But if we will mix something inside it, for example, you will mix NaCl, some salt inside it, so then we cannot say this is a pure substance because NaCl has different type of atom. Now, if you will mix NaCl here, so in the glass you have two type of atoms. One is water and other is NaCl. Then we cannot say pure substance because pure substance has only one type of atoms. Did you get it? What is a pure substance? Please confirm it so can I move forward. Okay. Now, pure substance have uniform composition and have consistent properties throughout the sample. For example, now, if you have a glass of water, if you will take some water from here, from this area, then and you will test it. Test means you will boil it. So this water will boil at 100 degrees Celsius. If you will take some amount of water from here and you will boil it in a different container, again it will boil at 100 degrees Celsius. So it means that if you have a pure substance, from wherever you take the small amount, so it will show you consistent, mean the same properties throughout the sample from wherever you take the small amount. Then pure substance have fixed boiling point and melting point. If you are given a glass of water, this is water, and they will ask you, okay, tell this water is pure water or not. And you know that pure substances, they have fixed boiling point and melting point. It means that if it is pure water, it should boil at 100 degrees Celsius. If it is not pure water, means something mixed, so it will boil more than 100, maybe 104 105 or 110, depends on how much impurities are there. So if they will ask you that how you know that water is pure or not, so for that you have a physical test. What is that? Boil the water. So water will if the water will boil at 100, so then you can say the water is pure. If it will boil above than 100, it means that it has some impurities. Now, element a substance that cannot be split up into simpler substance by chemical means. For example, if you have this small piece of aluminium, this is made of aluminium, all this one. If you will divide it into two parts, still it will remain aluminium. Divide it further, it is still aluminium. Divide it further, still aluminium. Divide it further, still. So ever you will go to divide more and more and more, still it will remain the same. You cannot change it into another substance. So that is the definition of an element. Element is a pure substance that cannot be changed into other substances. Molecule. Molecule means when two or more than two atoms, they join together chemically, so they make molecule. For example, you have oxygen. This is oxygen, oxygen atom. One more oxygen, when they combine together, so they will give you oxygen gas O2. Hydrogen. Hydrogen, two atoms, they join together, they will give you H2. So this is hydrogen molecule, this is oxygen molecule. Here, the same molecules are combining with each other. But if you have different molecule, for example, you have, here we can write hydrogen, and here you have chlorine. So when they join together, they will make HCl. So this is also a molecule. So simply, what is a molecule? When two or more than two atoms, they join together, so they make a molecule. And how they join? Chemically. Chemically means due to ionic bonding or covalent bonding. After that, you have a compound. Now, compound is really easy. For example, now we will see oxygen. Then you have hydrogen. Oxygen is an element, hydrogen is also element. Now you want to mix them, but before mixing, see the property of oxygen. What is oxygen? Without oxygen you cannot make fire. It means that oxygen is used to make fire. Hydrogen is also flammable, highly flammable. If you burn the hydrogen, it will burn very quickly. So both are burned very quickly. So these are their properties before you will mix them. But when you mix them, what you will get? Water. And water is used what? To put off the fire. If there is a fire, they throw the water so they can put off the fire. It means that before they have different properties, and after mixing they have different properties. If two substances, they are mixed chemically in such a way that they change their properties, so that new product is known as a compound. So this is a definition of a compound. In compound, for example, of oxygen is reacting with hydrogen and you are getting the water. So it means that these are known as reactants and this is known as products. So reactant has different properties than the product. In a compound, now they are elements or they are molecules. Now this known as compound and also known as molecule. In compound, the properties are totally changed. This is the main sign of a compound. Got it? Okay. Now, they have given the example here, oxygen and water, they have for example, they are molecule. Now they're saying that a compound can be also a molecule because it's made of two atoms. So here, if they want to see that impure substance or mixtures do not have fixed melting and boiling point. If you mix two things, so their boiling point will not be fixed. For example, if you have water and plus you have salt, if you mix them together, so this is known as mixture. And now water, before it has 100 degrees Celsius, now it will not boil at 100, it will boil more than 100. Now I will explain to you again what is the difference between them. For example, now you have two words now, mixture, and other you have compound. For example, you have iron and you have sulfur. Iron, you know that it is attracted by magnet. If you will bring a magnet, it will attracted by magnet. Sulfur, if you put water, sulfur, so sulfur floats on water. So these are their properties. If you take a container and you mix them together, sulfur plus iron, and mix the mixture like this without anything, just mix them. If you bring an magnet near to it, all iron will go and stick with the magnet. And if you put some water here, all the sulfur will come and start to float on the water. It means that you mix them. And after mixing, when you brought the magnet, so again, iron is attracted by magnet. They do not change their properties. So this type of mixing is known as mixture. But if I will mix them, iron and sulfur, and I will heat them, when I will heat them, they will melt together. And now they will make iron sulfide. If I will bring a magnet near to it, so iron will not be attracted by magnet. It means that now iron changed the properties. So now we cannot say it's a mixture, it's become a compound. In simple words, in mixture, elements keep their properties even after mixing. But in a compound, elements change their properties after they react chemically with each other. So this is they are talking about. So in this chapter, we will talk about mixtures. Mixture means you will just mix two things physically and then how you can separate them. So this topic is separating the mixture. So here they draw the flow chart. For example, matter. Matter can be divided into two types, pure substance and mixtures. Pure substance can be divided into elements and molecules. For example, elements, it can be hydrogen, it can be oxygen, chlorine. But molecule means H2O, HCl, they are in molecule, but all pure. Mixture means when you mix two things in such a way that they will not change their properties. So here we'll take some example. For example, element, what is the element? Sodium, carbon, hydrogen, aluminium, iron, sulfur, lead. Molecule means oxygen, chlorine, bromine, water. Compound mean NaCl, KCl, KBr, potassium bromide. All these are compounds. And mixture, salt in the water, air is a mixture of different gases, petroleum is a mixture of different hydrocarbons. So all they are known as elements, molecules, compound, and mixtures. Did you get it? Okay. Now we will start the separating the mixtures. Which method is used to separate the mixture? It depends on the nature of the mixture. First of all, we see which two things are mixed. According to that, we will choose the method of separation. For example, here they said that decanting or decantation. If they use the word decantation or decanting, so this is the same meaning. No need to confuse. What does this mean? It means that two liquids, if you have two liquids, or you have liquid and one solid, so then how you can separate them? Really simple. They're saying that if you have, for example, you have water, you put inside the water, you will put the soil or you put sand inside it and you mix it now. And the soil is mixed and all the water become dirty. So you don't have anything, you don't have a filter paper, you don't have any other instrument to, you can say, clean it or to separate it. So what you will do, you will take a container, and inside the container you put the mixture. Which mixture? You have soil and you have water. You leave this mixture and leave it after for 1 hour, 2 hour, or sometime 1 day or 2 day, depends on the quantity. So what you will see that all the soil, all the mud, it will settle down here in the bottom, and water will remain clean, water will remain at the top. So you can take this water and you can put another container. By this method you can clean it. In the old days, for example, maybe your grandfathers or my grandfathers, when they are taking the water from where? From the river. And you know that river water is mixture of water plus clay and mud. So what they will do, they will bring the river water and they put inside a container and they leave it for 1 day or 2 day. So what they see, all the mud will settle down here and clean water remains at the top, and they can transfer this water to the other container. In the modern age now, you have instruments, and those instruments are used to separate them. So that is known as separating funnel. What is a separating funnel? It is same like a container, you can see here, but down it has a hole. So when you put two things inside and you leave them up for some time, so one thing will settle down, other will remain up. The thing which is settled down, you can take it from here, open this tab and take all out. And then all is out, then you close it again. So by this way, you can separate two things. Normally, separating funnel is used for liquids. You have two liquids, and two liquids, one has low density and other has higher density. Any liquid which has higher density, it will come down, and which has low density, it will remain at the top. Then you open the tap and you can take it out and you can separate them easily. It can also be used for water and oil. You know that water has more density, so it will come down. Oil has less density, it will remain up, and then you can separate the water from it. So this is a separating funnel which is used to separate sometime solid and liquid, or sometime two different liquids and they have different densities. One is more, it will settle down, and which has less, it will remain at the top. So this is known as decanting or decantation. Did you get this one? Okay. Next is known as filtration. Filtration is means You have a liquid. Inside the liquid, you mix something. You have solid. When you mix the solid, it will not mix with it. It will not dissolve inside it. For example, you put sand. If you put sand, whatever the sand you will put, you mix it, it will not dissolve in the water. It will remain as a separate. So if you have a mixture in which you have a liquid and you have insoluble solid, the solid which are not soluble in water, so you can separate it with the help of a filter paper. So how you will use the method filtration, we will see with the help of this diagram. Okay, what this diagram shows, we will see here. You will take a filter paper. For example, you will take a funnel. This is known as funnel. This one, this device. Okay, and then you will take a filter paper. This is a filter paper. You will put the filter paper here, and then you will mix you can say the solution you made, the water and sand you will put inside it. Then what will happen? The filter paper will stop the solid up here, and it will allow the liquid or water goes down. And slowly you will find that all the liquid will come down and all the insoluble solid will remain at the top. So the liquid which will come down and you can getting in the beaker, it is known as filtrate, and the solid which will remain on the filter paper, that is known as residue. So this is very important, what is residue and what is a filtrate. If in the exam they will ask you, they will give you a question, they will ask you there is a mixture of sand and water, so what is residue? You say sand is a residue. And what is a filtrate? Water is a filtrate. So anything which will remain at the filter paper, so that's known as residue, and which thing will come down to known as filtrate. So this method is known as filtration. Got it? Next is known as evaporation. Evaporation is when you are heating something. For example, now you have a liquid, let's say you have a water, and then you have a salt. When you put the water in the mixer of water and salt, so when you stir it, you will mix it, so salt will mix completely with water. You cannot see the salt. It is become like water now, totally mixed. At that time, if you take a filter paper, so nothing will remain on the filter paper. Both salt and water, they will come down because salt is soluble. It is not like sand. So at that time, you cannot use filtration. So you will use evaporation. What is evaporation? You will take the mixture and you will take some mixture, you put on a tripod and you will heat it. When you will heat it, so what will happen? All the water will evaporate. Water will evaporate, and what is left behind? Salt. So this is the method how you can separate it. So solution, what is a solution? Solution is made of two things. What is that? Solvent and solute. Solute mean the thing which is mixed inside the solvent. For example, here water. Water is known as solvent, and the things which is are mixed inside, that is known as, for example, here salt. So salt is known as solute. So evaporation is used to separate the solutions. And how they will separate? They will heat it. Is it clear? Now you have crystallization. What is crystallization? Now it has few steps. For example, what you have? In the first step, you will do crushing. Crushing means you have a, let's say, piece of big piece of salt, like you have a small piece of salt, big one, and you want to make its crystals. What is a crystals? Crystals are very small particles or small size of anything which have a regular shape, and they have regular shape, so they are known as crystals. So this is like a stone, not crystal. So what you will do, first of all, you will crush it. For that you need two instruments. Maybe you saw this instrument like this. It is known as, in the lab, it's like this. You put the salt here, and then you have like a hammer, and you hit the hammer and you to it to small pieces. Okay, so this is known as pestle, and down one it's known as mortar. So you will hit it again, it will become like a powder. You will crush it and you will make it powder. Then second step, what you will do, you will dissolve in water, and you will take water, and whatever the powder you get, mix inside this water. And now solution is ready. Now this solution, you will heat it, and you will heat it. But don't heat all the water. When small amount of water is left, stop heating. Again, when you are heating, water will evaporate. But when small amount or very little amount water is left, then stop heating. Leave it cool down. When you will leave it cool down, after that it will become dry. So instead of big pieces, you will find very small crystals. So this is a method by which you can get the crystals. So there is a slight difference between evaporation and crystallization. In evaporation, you will heat until all the water will evaporate. Nothing is left, only salt is left. And at that time, this salt, in which form? It will be in powder form. But in crystallization, you heat it, but when small amount of water is left, stop heating. Very small. Let it cool down. Then you will get crystals. Here you are getting powders, and here you are getting the crystal. So that is known as crystallization. Got it? Please reply. Okay. Now they have described the steps here. First step, they are crushing. This is the pestle, this one, and this is the mortar, this container. You are putting in this one and crushing it. After crushing it, you are mixing here, and you are dissolving it, and they are heating it. Why they are heating it? Because they want to make a saturated compound. What is a saturated compound? For example, you mix sugar inside it. When you put some sugar, you stir it, it is dissolved. Again, you put more sugar, stir it, dissolve. Then you heat it, then more sugar dissolve. So one time will come if you will put more sugar, or it will not dissolve further. So that is known as, now this solution becomes saturated. So when the solution becomes saturated, you will just filter it. So what will happen? Saturated will come down, and which is not dissolved, it will remain up. Then you will do the evaporation and heat it. When small amount of water left, stop heating, you will get the crystals. And what you can do, you can cool them down, and then you can dry them, and sometimes you can, with the water, you can wash them also. So you will get the crystal. So this is a process of crystallization. After that, next method is known as simple distillation. In the simple distillation, you have two things. Once again, the solution. In solution, like salt and water. In evaporation, when you are heating the salt and water, water is evaporated. Water is disappear. You cannot get the water. Only you can get the salt. But if you do simple distillation, you will get the salt, plus you can also get the water, both of them. So this is known as simple distillation. How it is carried out? You will take the solution, then you will heat it, so the water become into vapors, and then these vapors, they cannot go from out here because it is closed. They come here, and here is a condenser, cold water. So cold water around the pipe. So the steam or the vapor, again they convert into water and they come down here. Slowly, slowly, all the liquid come here and solid remain here. So in this method, you can get solid plus liquid. So this is known as simple distillation. Okay, we are talking about here the simple distillation, and we said that simple distillation is also used for separating two substances. For example, one is solid, which is soluble in a liquid. But what is the difference between simple distillation and evaporation? Because in evaporation, you are getting only solid. Liquid is evaporated in the air. But in simple distillation, you can get both solid here and liquid here. And the device which is used for this one, so that's known as condenser. You can see here. From here, cold water go in, and then it is around. It will not mix with here. It is just around this one, and hot water go out. So this is known as condenser. What is the function of the condenser? To convert water vapors again back into liquid. Not only water, any liquid vapors, they convert into liquid again. So in the exam, you should know the labeling. You should know this is a solution, or this is known as round bottom flask. This is known as tripod stand. And here they can use heater or split lamp. This is known as condenser, and this is known as beaker, this one. Okay. And condenser, you already told you, so you should know the labeling. So what is the first step? A solution such as salt and water is heated to evaporate the water, leaving behind the salt. So water will evaporate, salt is left behind. Then a cold water cycle is run around the water vapor condenser. So water vapor is going like this. When they reach here, so the pipe become cold, and the pipe become cold, so it will condense and liquid, the vapor become liquid again. So by this way, you can separate two things here, and that is known as simple distillation. After that, the other method is known as fractional distillation. Fraction distillation, when you have two or more than two substances. For example, you have liquid and also liquid, or you have gas plus gas. Then you will use the fractional distillation. You cannot use simple distillation. Simple distillation is used when one substance is solid, other is liquid. Then you will use simple distillation. But fraction distillation, you have liquids are mixed together and gases are mixed together. But they mix in such a way you cannot see them separate. Means you cannot say this is, for example, I mix something. For example, I mix what? Water plus ethanol. When I mix them, they look like one substance. You cannot say this is a water drop, this is a ethanol drop. But if you mix like water plus oil, and I mix them, here you can see this is oil here, here. But in this, you cannot find them. They are miscible. Miscible mean they mix with each other. And when two liquid are mixed, but still you can see they are away, they are different from each other, like oil and water. So then that's known as immiscible. So this is used to separate the mixtures. Which mixture? Miscible mixtures. Like air. Air is a mixture of nitrogen, oxygen, noble gases. This one. So you can separate them also. So that is also fractional distillation. So here we will see now the fractional distillation. They're saying the fractional distillation is a separation of miscible liquids such as water, alcohol. This method involves the following steps. Number one, mixture is heated until the liquid with the lower boiling point start to evaporate. An electric heater is usually used to safety precaution to heat alcohol due to its high flammability, because they cannot use the spirit lamp. In spirit lamp, you know that fire comes out, and that fire can go to alcohol and all alcohol can burn. So they use electric heater. So they put the beaker, only heat goes, no fire. And then they are using a fractionating column. We will see that then they are using condenser and the round bottom flask. We will see all this one in the next diagram. See this one. Now, try to understand really easy. You have two liquids here. Let's say one is water and other is you have alcohol. You know that boiling point of water is 100 degrees Celsius and alcohol start to boil at 78 degrees Celsius. They are mixed together. When you heat them with the help of heater, so they start to boil. Temperature, let's say before temperature was 25 for both, temperature start to increase. It's become 50, it's become 70. When the temperature will become 78, what will happen? Alcohol start to boil. Alcohol convert into vapors and alcohol start to go up. So when you have an electric heater, so you maintain the temperature, let's say till 85. Don't increase the temperature more than 85, because if the temperature will go 100, water also become vapors. So you have to only convert alcohol. When alcohol convert into vapors, it will go up. So this area is known as fractionating column. What? Fractionating column. In this fractionating column, let's say when the vapors are going up, the temperature is 90 for them. They are going up, temperature become. As they reach up, the temperature start to decrease. Maybe it's become 85. Maybe temperature become 80. But temperature here should not be less than 78. If the temperature here is less than 78, alcohol again fall back. So maintain the temperature more than 78. So alcohol will move from here. And when alcohol reach here in this pipe has a condenser. The condenser will cool down alcohol and alcohol will come here. Water will remain here. So by this method, you separating two liquids. And why you separated them? Because they have different boiling points. Water is 100 and alcohol is 78 degrees Celsius. So alcohol, it boils and comes here and then comes this one. So this is how the fractional distillation happens. Step number one, the water vapors condense at the glass beads. So here water. So they're saying that, okay, no need. Even if you are heated 100, both water will go up. Let's say water is also going up. Alcohol is also going up. But here temperature become less than 100. Let's say temperature become 99. What will happen? Water will fall back and alcohol will remain continue going up. Understand? So here, no need to worry about that, how you can maintain the temperature. Simply heat them. Water boil at 100. Water also become vapor. Alcohol also become vapor. But when the water will reach here, the glass beads, they decrease the temperature from 100 to 99, 98, water will fall back. Alcohol, because its boiling point is 78, so it continue this one and it will collect it here. This is the first step. Second, cold water in the condenser turns the alcohol vapors again into alcohol drops. Third, alcohol condense and you can get it here. Did you get this method also? Please confirm.
Yes.
Okay. After that, another method which is used, that is known as chromatography. Known as chromatography. Now, chromatography is used for different colors and also used for some type of, you can say, um, in medicine fact, you can say industry, it is also used different colors and also used to check the purity of a substance. Now, how it will work, we will see that one. First of all, see the definition. Chromatography is a method separation of two or more solids which are soluble. An apparatus like one shown in the bottom is used to separate two different mixtures of ink according to the following steps. Now we will see the steps. Step number one, a line is drawn near the bottom of the chromatography paper using a pencil. So this line is known as a baseline. Okay, now, for example, you have a solution. In this solution, I will say to you, there are different colors are there. Somebody mixed different colors. I want to know that which colors are there. For that, I will use the procedure that is known as chromatography. Known as chromatography. What is a chromatography? You will take a paper. You will take a paper, and this paper, it is known as chromatogram. And this is sometimes they take filter paper as a chromatogram. This is a special paper. So they took a paper. Then with the help of pen, they draw a line, pencil. With the help of pencil, they draw the line. You know the lead pencil. They draw the line. Now the question comes, why they use pencil? Why they are not using a pen? Because the pencil will not leave its color. If you put inside the water or any solution, this line will not dissolve. If you put any ink color here, that ink will dissolve when you put inside a solvent. So first thing, what you will do, you draw a line at the bottom of the paper. This line which you draw with the pencil is known as baseline. So this is the baseline. After that, the line is drawn with a pencil because graphite pencil does not dissolve in the solvent. They're saying the baseline must be always above the level of the solvent. Okay, now what you will do, you will take a water. For example, here you take container. In the container, you put water. And now you will bring this this paper here like this. You will dip inside this one. But make sure the baseline, this baseline which is here, this baseline, it should not be go under the solvent. It should remain at the top because solvent is still here and baseline is up. This is a precaution. After that, you will take a dropper. You will take one drop of this solution in which you have different colors and you put here on the baseline one drop. And when you put this one, so what will happen? Let it dry for some time. In the same time, what will happen? The water or the solvent is start to absorb by paper, and it will rise up in the paper. As you put a tissue paper in a water, so water start to rise in a tissue paper. In the same way, you will find that water start to rise, or the solvent which is here, it start to rise in a paper, and you can feel that it's becoming wet. And then after some time, it will stop rising. Only up to that level water will go. It will not go above than that. So the line where the water stop, that is known as solvent front. Solvent front. Solvent front. The down line where you put the drop, that's known as baseline. And where the water stop and it not rising more, the end point, this is known as solvent front. After that, you will take out the paper. You will take out the paper. Okay. And then let it dry. Here we can see the ink mixture are put the baseline by using a dropper, as they did this one. A chromatography paper or chromatogram is placed in the beaker. Paper is suspended in a way that solvent could only touch the bottom, only, not the baseline. So the baseline will remain up. The solvent travels up to the chromatography paper carrying the soluble substance. So when the water will go up, it also take this solvent with it, like this line, like this, take them up. So then after that, you take out the paper, and then you will see. Now we'll see with the help of diagram after that what you will do. See here, this is the chromatogram, and you put in a solvent here, and this is your baseline. And after that, when water stop to rise, you will bring. So this paper will be like this. Here they took two samples. We took only one sample. You can take even two drops. For example, you have one mixture here, mixture A. You have one mixture, another mixture here, mixture B. So you take one drop, put here, and other from you want to put. So in this way, you can check even two mixture together. No problem. So now what you will see, when the paper will become dry, you will see this one. Before it is one spot, now you will find four different colors. One color, two color, three color, four color. So it means that the mixture A, the mixture A is a mixture of how many colors? One, two, three, four. And mixture B, it is a how many colors? One, two, three. So even you can see the colors. And if you will not see the colors clearly, which colors they are, don't worry. For that, you have a different method. But for this one, it will tell you that how many substances are there. For example, I put a mixture here like this. This is a paper. And here is the baseline. I put a drop here. But after hanging like this, I got only one spot. So it means that this mixture is pure. It has only one substance inside. If I will get two drops, two spots, it means this mixture is made of two substances. So like this, number of spots, it will tell you how many things are mixed inside it. So this is a method which is used to find that substance is pure or not. And if it is not pure, how many other substances are mixed inside? One, two, three, how many? There are four. So this is a chromatography. It is used to check the purity, because purity of a substance is really important in medicine. When they are making the medicine, so purity is really important, or also in food industry. So this is the method how they do the chromatography. Now, sometime you will not get the color clearly. This you cannot see which color this is. You cannot see which color, but you can get a, you can see there is a small spot, but you cannot see the color. For that, a method is used to find what is this, what is this. That is known as RF value. Known as RF value. What is RF value? We'll see it now. Now they said that, okay, if you got the chromatogram, you mean you got that paper out of the liquid and you have 1, 2, 3, 4 spots. So how you will tell that what are the substances, it is pure or not? As I told you before, if only one spot, it means pure substance. If more than one, it means not pure. Sometimes you cannot see the spot clearly. They are really, really dull. They are almost very light. You cannot see them. So they have a spray. They put that spray on the paper. So these become more visible. The spots become more visible. So this spray is known as locating agent. The spray is known as locating agent because it helps you to locate the spots. So this is what is a locating agent. Locating agent is a substance which will make the, you can say, spots more visible. Now, this is how you will make them visible. Now they become visible. Now, but you don't know the colors. There is a spot, but you cannot see which color. You cannot see which color. They are like a mixed. So how do you know? For that, they have a formula. What is the formula? For example, this is the paper. In this paper, you have, this is the baseline. You put the spot here. Then you got two spots. One spot you got here, other spot you got here. Got it? So what is this? This is baseline. This line. Then I told you that water will stop at some point. So that point is known as solvent front. This line. So now let's say this is point A, this is point B. So first you will find what is A. So for A, what you will do, you will find the distance from baseline to the spot. And you also find the distance from baseline to the solvent front. So for example, for A, what is a value of A? Distance traveled by sample. Let's say this distance from baseline to A is, let's say, 5 centimeter. So you will write here 5 centimeter. Then you see the distance traveled by the solvent from here till here total. Let's say that is 10. So you will write here 10. So what is the answer? 5 over 10. It is 0.5. No, yes, 0.5. So this is the value. Then you see B. For B, again, you will do RF of B. So let's say B is 8 centimeter. And this is remain same, 10. So that is 0.8. So the value of A is 0.5 and value of B is 0.8. So these are value, which value? RF value. Then they have a chart in the laboratory. In the chart, it is written that if the value is 0.5, it means it is red color. If it is 0.6, it is blue. If it is 0.7, it is green. If it 0.8, it is orange. All the values are written. Then you see this chart. Okay, my value is what? 0.5. So here, which color? Red. So you say A is red. Then you see what is my other value? 0.8. I will see where is 0.8? Here. What is the color here? Orange. So other color is orange. So you can say this mixture, it is a combination of red and orange. So this is how you will find the different colors there. Tell me, please, did you get this process or not? Confirm it. Please confirm. I'm waiting for your reply. Okay. Now, here, locating agent, I told you, are used to produce colors in chromatography for colorless substances. For example, sometimes they mix the things. I told you in chromatography, not only colors, it is also used for different other chemicals like amino acids. For example, you have amino acid A, amino acid B. They are colorless. When you mix them together, so even also they colorless. When they put them on a paper and they go up, even they are colorless. You cannot find the spot. So then you use locating agent, they will get the spots. So that is why you are using locating agent. Then RF values, I told you how to find. When you find the RF values, after that you can see the chart. In the chart, you can match the value and see what is which color, or sometime also written. If the RF value is 0.2, it is amino acid A. So like this, they can also tell. But in the exam, they will not ask you that 0.8 is for what. No, only they will just know this formula. Or sometime they will give you the values, you will just calculate it, and then they will give you a table. Whatever the answer you get, see in the table and tell the substance. This is only thing you have to do. Now, how you can test the purity of a substance? We'll see now. How you can test the purity of a substance, that any substance is pure or not. For example, I told you before that any pure substance, it has fixed melting point and boiling point. If you have pure substance, it will start to melt at a fixed temperature and it will also boil at a fixed temperature. For example, now see these two. You can see here the temperature is increasing, then line become little bit curved like this. Again, when it reach at boiling, again it is little bit curved. But here you can see this is a straight line. This is the straight line. So it means that all the liquid start to boil. Here all the solid start to melt. But here they are melting slowly. Here boiling slowly, not on fixed temperature. Some boil here, some boil here, some boil here, some boil here. Some melt here, some melt here, some melt here. If you get a graph like this, it means this substance is not pure, not pure, or it is impure. But if you get the straight line like this, which shows that one boiling point, one melting point, not like this range, so that is known as pure substance. So whenever you want to know some substance is pure or not, the best thing that melt it or boil it and check the temperature. If it is boiling at a fixed temperature, then you can say it is a pure like this graph. And if it is not boiling on a fixed temperature, because maybe it's starting from 100 and 110, still it is boiling. Here, starting from 0, here and maybe minus 10, it is melting. So this is not pure. So this is the main difference, that how you will check the purity of a substance. Whenever you mix, for example, you have water. If this is pure water, what is the temperature, the boiling point of pure water? 100. What is melting point of pure water? 0. If you add any impurity, for example, you add some salt, water will not boil at 100. It will boil at 105, 110, 115. So it means that when you add an impurity to a pure substance, its boiling point increases. The same water with the salt, if you will freeze it, it will not melt at 0. Maybe it will melt at -5. Before 0 start to melt, maybe -10. It means that when you add impurities, melting point decreases. Melting point decreases. Once again, when you add impurities to a substance, pure substance, its boiling point increases, but its melting point decreases. For example, water was boiling at 100, but when you add impurity, it will boil above than 100. Before, water is melting at 0, but when you add impurity, it will melt before 0, like -5, -10. So this is how you will know a substance is pure or not. Did you get it? Please confirm.
Yes.
Okay. After that, we talk about impurity, purity. From that time, we are talking about why this purity is important. This purity is really important for making medicines, because when they are making the medicine, if any impurity will mix in the medicine, it can cause really big health problem for the patients. So then they need really pure things. Also in food manufacturing, when they're making the food, different type of food items, so they also need the pure substance, because any impure substance can harm the health of the people. So always when in the medicine and the food industry, the chromatography is carried out, really important to check the impurity of a substance. Sometime in the exam they ask a question that why purity is important. Then you can say purity is important in medical field and food stuff field. Why? Because any impurities in medicine and food can cause the health issues in the people. So this is why it is important. Now here again, this is you can say uh, summary, the summary of the method which are used for separation. For example, they said that if you have the for example method, this is the method: chromatography, simple distillation, crystallization, filtration, diffusion, or fractional distillation. So why they used type of mixtures. If you have colored mixture or you have organic mixture, means you have some amino acids and other thing, so you use chromatography. If you have a solution, so you will do simple distillation. If you have a solid which is dissolved in a solution, then you do crystallization. Then if you have a insoluble solid which is not mixed in liquid, you do filtration. Then diffusion is for gases. Liquid fraction distillation, when you have liquid mixed together or different gases are mixed together, you will do the fractional distillation. Now we'll see the other thing, that how it is carried out. I told you before, we discuss all the method quickly. It is the more soluble, okay, travel further, which is can say more soluble. It will travel faster and go above in the chromatogram paper. Then the RF values are calculated, and then you find the substance. How you can do simple distillation? Water is heated and then condense with the help of condenser. And what is crystallization? Evaporation, cool down, filter, crystal, and dry with the filter paper. Filtration, filter them, and you will get the residue on the filter paper and filtrate down. Then the gases, again, you will diffusion, you will the you can say the lower molecular masses, they will move faster and they already separated. And if fraction distillation, you will boil them, both will convert into vapors. Then you cool down, one of them will convert liquid, fall back, other will remain and separated other one. Example, chromatography example. mixture of inks, mixture of amino acid. Simple distillation, water from the sea water. Crystallization, copper sulfate crystals. Filtration, separation of solid precipitate from a solution. Diffusion, mixture of gases. Fractional distillation, crude oil or liquid air. They are separated by this one. Okay, then you have next page. Here, the lab equipment. Please go through this one and you should know the labeling. Very, very important. Okay, in the paper 6, you will find the question regarding this one. What is this evaporating dish? What is this Bunsen burner? What is this filter paper? What remain on the filter paper? Residue. This funnel is known as filter funnel, and anything which come down here, that's known as filtrate. This is what separating funnel. Liquid with less density remain up, more density come down. This rod is known as stirring rod, which are stored used to mix them. This is what beaker, and where it is kept tripod. This is Bunsen burner. This is filter funnel. The dish is evaporating dish. This is pestle. This is mortar. You should know these equipments. Then when we talk about, when inshallah we'll do the electrolysis, we'll see also this one, the battery, light bulb, anode, cathode, we'll see them when we'll solve the, you can say the electrolysis questions. Then here again, the chromatography, you should know. What is that? This is baseline. This is chromatography paper. Where the liquid stop, that's known as solvent front. This is lid, chromatography paper, the beaker. You should know this one. This is the labeling, important. Then you have thermometer. This one, fractional distillation. You have thermometer. This is condenser, water in, water out. You have glass beads, and from here till here, fractionating column. This is mixture of liquids, then tripod, then here, anything come here, that's known as distilled. So as I told you that, then you, for example, this is the labeling, and these different devices or equipments are used in the chemistry lab. So you should know, for example, this tube is known as delivery tube. This is a gas syringe. Then you have the tongs. Then you have the clump where you in a stand where you hold something. Then you have thermometer. Then you have balanced conical flask, same this shape. If the flask is like this, that is known as round bottom flask. And here you have spatula, which is used to like a spoon. And then you have the small, like a tray or a small dish, like a glass, when you put small things there. Then you have the tripod. All these things, they are really important for the paper 6. You can see here. So please go through them and try to, you can say, memorize the names. That one. Then if you go to the next page, so then you will find that different instruments which are used. For example, stopwatch is used to measure the time. Thermometer is used to measure the temperature. Balance is used to measure the mass. Then you have volumetric pipette. This one, it is used to measure the volume of liquids accurately up to 25 cubic centimeter. Burette, this one, will also study when you will talk about the preparation of the salt. So you will put the acid here, and then it is used to measure the liquids accurately up to 50 centimeter cube. Measuring cylinder, you can see this one. And then after that, you have gas syringe, which is used to collect the gases. After that, you have the spatula, like a spoon, I told you. Then you have heat pipette, transfer liquids from one. It's like a dropper. You will just press this balloon, air will release, you will put inside a liquid, and then you release it, and liquid rise this one. And if you want to drop somewhere, again press, the liquid come out. The steering rod, which is used to mix the things. So this is the known as steering rod. After that, separating funnel, we just discussed before. This is a funnel. The less density remains up the liquid and more down like this. Then you have the gas jars. You can, where you can collect the gases. This is a gas jar. Any gas come and they're collected here. So that's known as gas jar. After that, you have pestle and mortar. We discuss that one. That this is known as pestle and this is mortar. They are used to crush the things. After that, you have a hazard. What are the hazard? Whenever you want to do an experiment and that experiment, any gas produce, it is poisonous. So you will use the fume cupboard. Fume cupboard is like a cupboard and you will do the experiment inside this one and it is covered from all. Gas cannot come out in the lab. It has a pipe which is going out of the lab exhaust. So this type of cupboard is known as fume cupboard. And why it is used? When the poisonous gases can be produced, then they can be dangerous. To avoid that one, this is a glass cupboard. You put the reactant inside, reaction happen, anything produced, it will go out automatically. Heating flammable liquid. When you are heating a liquid which is flammable, like alcohol, it catches the fire very quickly. So use the electric heater. Poisonous chemicals. Whenever you have any chemical which is poisonous, so wear the gloves. Also, you wear the safety goggles, mean glasses. The heating a tube. When you are heating a tube, no stopper should be placed. For example, if you have a tube, when you are heating it, so don't close any side of it. It should be open from both sides, so the hot air can go from this side. Strong acid or alkalis. If you have strong acid and alkalis, you are making the reaction. So what you will do, wear the gloves and the goggles to protect your hands and to protect your eyes. So this is the end of the unit 2 and now these are the past paper questions and they are like 80 questions I have put for you. So this is only multiple choice questions. If you go through them, you can find them is inshallah easily already solved. You can see them, they are already solved and you can find the question for separating mixtures and you can also find the like chromatography questions also, you see, which is used all this one. You go through this one and if you have any question we can discuss in the next class.